and welcome to day 4 of our 9-day webinar series, Disrupt or Be Eliminated. Friends, I am Bimal Patwari and I founded Pinnacle Infotech 29 years back. As you can see, my name starts with BIM and my visionary parents named me after BIM more than 50 years back. Probably I was destined to drive BIM in the AEC industry. Pinnacle is the leading global BIM service provider to the AEC industry in more than 40 countries. We cover the entire spectrum of BIM construction, starting from design to construction and facilities management across all industry verticals. Our close association with different segments of AEC industry has helped us to understand the pains of the industry, and our team has taken a sincere attempt to address these by stretching technology and making innovative use of it. It is our passion and cherished mission to increase the efficiency, reduce cost, and meet deadlines by providing innovative solutions. Friends, today's session will be an hour long, where we will take you through our presentation for 45 minutes, and in the last 15 minutes, we will discuss all the questions you may have. So please keep submitting your questions throughout our presentation for our team. Please keep typing your question in the question box window. Right now, everyone is muted to avoid background noises that may be a distraction. So let's get started. Our topic today is laser scanning. We all know how laser scans are helping to scan existing buildings and create accurate as-builts. We now take laser scan to the next orbit, where we are working with our partners to revolutionize construction. As they say, seeing is believing. So today we will be showing examples from iconic projects to demonstrate the use of lasers in construction management. Today we are fortunate to have two great panelists and speakers amongst us. David is the segment manager of the Field Technology Group with Trimble Buildings. With over 20 years of AEC industry experience, promoting technology and collaboration among design and construction teams, David brings a comprehensive understanding of BIM and virtual construction. Through the use of 3D capture and positioning technology, David is focused on the development and implementation of tailored solutions to advance the field productivity of AEC contractors, engineers, and architects. Leonidas, Masters in Civil Engineering from Liverpool University, is the BIM director of Pinnacle Infotech in Middle East. He has been passionately implementing and delivering BIM in iconic projects around the world. Earlier, he worked at CCC and was involved in the construction of major terminal buildings in Abu Dhabi. Leonidas is currently working as BIM project director in one of the most prestigious stadium projects in Qatar, where he is involved in innovative usage of BIM technology and has been experimenting on the edges of technology. We are really lucky to have two veterans from the industry who have used and implemented this technology, and we will benefit from their experience today. Today's key learnings is the innovative use of laser scanning for improving construction quality, improving site safety, and getting ahead of schedule. The laser scanning for construction progress management, laser scanning for inspections and approvals, laser scanning for quantity estimation and contractor bill approval. Friends, even I did not believe 1 year back that laser could be expanded for so many activities. But it's amazing, and Pinnacle has shown that how the technology can be expanded for various applications on the field. Lasers, as we all know, 5 years back, they were quite costly and they were quite big. Today, they are much cheaper in a package of $30,000, as I was told, that today, we can really get a high quality laser which can do the functions that we are going to show you today. So as we know, the lasers, they analyze the real world objects to collect data on its shape and appearance. The collected data are used to construct the 3D models, and a very highly accurate field representations are made by the use of laser beams, generating millions of points for every scan. And we can quite quickly capture all the complete project details. And as I said before, the important benefits of using laser is to improve the quality and accuracy. It takes planning and detailing to a different level on site. We can get immediate feedbacks, and the real-time scans can be done and accessed immediately to improve operations. The scanning process can be done in minutes, whereas conventional could take hours to do the same survey. And I would leave the panelists to give the more details of these and how they are reducing the rework and eliminating the rework. We are reducing the physical effort and streamlining the coordination on the site. So today our focus will be on the construction management and how the laser can be used. So now I will pass on to Leo, who will take us through the great project that he is doing and the wonderful job his team is doing.
Bimal, thank you very much for your kind words and introduction. Ladies, gents, I would like to welcome you and thank you for registering in our webinar. The subject of today's is focused on the advanced implementation of laser scanning in construction. We'll start by giving you a short introduction into the fundamentals of our project, and thereafter we'll proceed into deeper subjects, into advanced practices of our implementation. Our project is the Lusail Stadium project that is located in the Middle East region. The new facility is scheduled to host the opening and final matches of the FIFA World Cup in 2022. The construction officially began 3 years ago on the 11th of April 2017, and since then Pinnacle is heavily involved in its development drastically. Pinnacle is the main contractor consultant for the development and the implementation of building information management and digital practices. The main contractor is a joint venture between the local HBK contracting company and the CRCC, the China Railway Construction Company, one of the largest construction and engineering enterprises in the world in terms of revenue generation. If we go into project specifics, our project incorporates in its design a variety of technological innovations, having unique features as, for example, the enormous gross capacity of 92,000 seats. The bowl is an air-conditioned seating arrangement that incorporates air diffusers and under-seat cooling nozzles to pump cool air into the stadium during the tournament phase. The most unique feature, though, is the construction, erection and installation of the world's largest internal roof structures, which span over more than 350 meters. The fields of laser scanning implementation in our project is focused in the as-built data collection, in the measurements and digital project controls. We exercise a lot of tasks in terms of earthwork management. We're making advanced implementation deflection and deviation analysis. We also support the construction staged impact analysis. We work digitally to support inspections. And generally speaking, we are having a close integration with the construction teams by supporting them with virtual erection and simulation studies. The consistent collection of as-built data in point clouds allows for a more efficient management of site activities in a way I would say that was not possible before. It drastically eliminates risks and uncertainties, allowing for more prefabrication of site. It also reduces human errors and error-prone observations, giving the opportunity to the end user to process and evaluate an enormous amount of data. The consistent collection of point clouds allows the comparison between two principal stages, the design and as-built models, which can be somehow extracted in drawings. We can obtain archival records of our project at any time interval, and generally speaking, we document critical milestones. It is also worth noting that BIM-centric project management have an outstanding integration with the majority of point cloud solutions, which boosts the overall general contractor's performance. Specifically, in our project, the use of laser scanning is extremely beneficial and is highly recommended for monitoring and control purposes, which are primarily related to construction performance requirements. This may be applicable for large piers, buttresses, log span beams, and overall, let's say, complex building components. The main function is based on the overlay of BIM models that are developed to extract sub-drawings. Those models are called construction models or LOD 400 models, which are overlaid against point clouds. That overlay can be used for multiple purposes to support multiple scenarios and reports that we can see in the below slides. If we start studying cases by case, some exercises that we have already undertaken, in the following slide you can clearly see how the findings of a laser scan analysis were extremely useful for main contractors. So you can clearly see an assembly of steel elements that was conducted for the sake of evaluating the erection of a truss beam along with its superstructure in terms of construction tolerance and deviation analysis. You can clearly see how the point cloud itself is representing all deviations in a heat map, which is used for construction verification purposes. However, construction cannot be interpreted as a standalone activity. There are many dependent sequence activities and staging processes that must always be taken into account. The current slide now represents the post-erection analysis of a composite truss beam and cantilever beams. Our project considers a modern requirement of sports architecture, which it is very strict in maintaining unobstructed views, having a very efficient utilization, making clear sight lines for the spectators and providing ample spaces that it pushes usually the design into its limits. The below extract from BIM clearly shows how a truss beam and a set of cantilever beams they support the superstructure of the stadium, which is equivalent to a 5-story steel building, which carries also the sitting ball.
Leo, we cannot hear you. Can you check that? Leo?
Hello? आवाज नहीं आ रही तुम लोग?
Yes, Prachi, Bimal, can you hear me?
Yes, we can hear you now.
Okay. How many slides did we lose?
I think we are on the slope analysis on the decking slab.
Okay.
That is the slide we can. Yeah.
Okay. So apologies for this inconvenience. In live demonstrations, it happens. Just in case that you cannot receive me well, please let me know. Okay.
Sure.
Okay. So I was referring to the staged analysis that the general contractor has undertaken, since we are dealing with a special structure that has pushed the design limits of the structure itself to too much. So what I meant to say is that the accurate monitoring of as-built conditions was achieved by using the laser scanning and evaluated in a BIM-based environment. The current approach enabled the general contractor to have a better understanding on the structure's performance and evaluate thoroughly risks associated with dependent construction activities. In our project, laser scanning is also used as a supplementary material for digital inspection purposes. So although we have allowed for systems like BIM 360, which are the digital inspection request, we also support those inspections by efforts and the tasks undertaken by the point cloud itself and through laser scanning. So we can clearly see in this slide how a 9D400 model of one anchor plate is overlaid against the BIM model, and we created a deviation analysis report, being able to hand over the part of the work from the reinforced concrete subcontractor to steel. Next, please. Now, of course, laser scanning can be used in simpler tasks that may be of equal importance as well in tasks related to the floor levelness and flatness. In projects like our project, which is consisting of multiple building units that they form a complex, maintaining the floor leveling consistent is of paramount importance. The floor levels usually accommodate steel embeds, steel columns, and you have to ensure that there is a consistent leveling so that to receive those embeds along with the application of screed and flooring material. Next slide, please. Thank you. Of course, as a part of the broader implementation in our project, we use the laser scanning in all the building components, including the facade. In projects like the Lusail Stadium project, which is under a design and build type of contract, sometimes the works may be executed concurrently. And I mean that although the construction works or MEP works may proceed on site, some elements of this project may be under design. In our project, we had the opportunity not only to make studies and overlay construction models against design models, but we also somehow boost this activity by collecting point cloud data and directly comparing with elements that might be under design on that stage. So this gave us the opportunity to have a streamlined process on site with elements that may be in a different staging, some released for constructions and under design, for instance. Of course, when we are talking about facade is a critical component for the aesthetics of project, which has an interface with the primary steel elements through the brackets. So in our project, we have to account for approximately 4,000 brackets, that each individual bracket was coordinated against other interfaced elements like MEP or other structural works against for issuing the brackets for fabrication. So the project, generally speaking, saved a lot of abortive work and a lot of delays by having all the elements fabricated and installed at one go. Of course, okay, again, digital handover was of paramount importance and extremely useful for the bracket for the facade installation. Since the point cloud can capture millions of points within a very short period of time, the laser scanning was used so that to hand over the primary steel package from the steel subcontractor to the facade subcontractor, having a full monitoring of the deviations and an evaluation that the handed over part of the work lays within the acceptable range of tolerances. Of course, MEP cannot be excluded by the laser scanning strategy, and it is primarily related in somehow verifying the MEP works on site. So, complex and heavy-duty MEP arrangements have been scanned and compared against our construction models in different stages. So, especially for heavy-duty MEP rooms, laser scanning was used to verify that all assemblies are going as planned without experiencing any actions that they may cause delays or they won't conform to the tolerances. The next slide is a slide which clearly shows an example of good execution on site. As you can see, the construction model, which is used for extracting shop drawings that are released for construction on site, is met at a very good percentage. And the point cloud in this case verifies that all the inputs that have been put in the construction model are implemented on site without deviation. So point cloud is also somehow an important index in evaluating the site performance. Another use, which is extremely useful, is the builder's works validation. Usually the builder's works are executed prior to the commencement of MEP works. This is a representative example of comparing the cutouts of one suspended floor against the drainage system. So we had the opportunity not only to verify that our builder works are implemented, but we have managed to implement changes through our change management workflow by using the point clouds as the sole source of information for or either releasing the drainage works on site for construction or implementing changes on the systems. The laser scanner and the scanning, generally speaking, was also used in the different nature of works, such as the earthwork management. In our project, we implement a great stockpile area of filling material coming from the site itself, and we also supply aggregates to our batching plant. The close monitoring of the aggregates quantity was of major importance since the current times, due to COVID and other parameters, there is a shortage of materials on site, in the market specifically. So laser scanning provides us the opportunity to rationalize the volume calculations by implementing a very accurate input, so that fact that enhanced our output, which is the volume calculation. In a gross percentage, each stockpile that is evaluated by the traditional method and the lasers against the laser scanning, we always get in with approximately a variation on the quantity by 10%. So in other words, that means that the laser scanning input can optimize the volume calculation by approximately 10% and give us more accurate results compared to the deposits we have in terms of stockpile and aggregate materials. Without any doubt, the instruments, the equipment we use for making all these studies is our laser scanners. So there is a special process for the laser scanners to be always calibrated and up to date. So fortunately, today's technology provides us with a lot of tools in making self-calibration quite frequently, fact that ensures that whenever we want to go deeper into accuracy and achieve measurements, higher quality measurements, self-calibration is always a tool that the modern technology incorporates, that it's extremely useful for our own performance. Now, the next part of our presentation is slightly different compared to the previous one. That's because we will be presenting you how the laser scanning is implemented in an end-to-end solution to support a very specific requirement for the roof, primary steel and facade structures. The main requirement that we had to respect in this workflow was the sensitivity of the mentioned structures to deformations. That means that we have to deal with highly deformable elements that for each stage the deformation should be controlled and should be federated within an agreed framework of tolerance. So the main aim was to establish a workflow that could ensure the proper handover between different stages for different parties. For that purpose, Pinnacle created a composite beam and laser scanning roadmap comprising of 6 control stages. Those stages are considered as the pillars of a successful project delivery for that part of the work. Starting from the first stage, which is the fabrication stage, that took place on-site in China, all steel components were fabricated according to the LOD 400 fabrication model in Tekla and properly scanned by the use of industrial handheld scanners for verification purposes. Afterwards, the vast majority of the steel elements, which is consisted of built-up sections, were categorized in certain assemblies that they had to receive a trial assembly. This trial assembly was a requirement of the general contractor to the shop, to the fabricator, so that to ensure that prior to shipping the steel elements will be of the proper geometry, not in a form of parts, but in a form of full assembly. So several trial assemblies took place. They have been also scanned and evaluated in a deviation analysis report. So considering that case, even the fabricator was aware before ship the order to evaluate the range of tolerance that is somehow shipped to the site. This also provided the assurance to the general contractor that receives material with the cut length and shape as per the design requirements. Now, upon delivery of all these built-up sections that they were received by containers and shipped into the project location, the fit-up works commenced. The fit-up works implemented a temporary arrangement of welding. It's worth noting that our package is primarily related to welding connections. So we apply a temporary welding for all these steel assemblies, and we laser scan it for the sake of evaluating its accuracy. Afterwards, we can move to the next slide, please. Afterwards, once the temporary fit-up works were confirmed that they meet the proper alignment of the members, we proceeded with the full welding on site. So in your pictures, you can see a V-frame, that it's worth noting that the size is extraordinary of those segments. So we're talking about sizes that they may exceed in length the 220 feet. And on the other side, each sectional profile may have a size of 6 feet by 4 feet. The critical and the key challenge that we had to meet in this process was that during the full welding process, the internal stresses that the welding exerts into the section creates excessive amount of expansion and contraction into the members that in certain cases creates a local distortion. So the aim of the laser scanning in this stage was to evaluate the magnitude of the welding effect over the final assembly on ground, including the temperature effect from rising from the daytime to the night cycle, which is also, in considering this size of elements, is quite considerable. Of course, the point cloud itself, upon the full welding process, it becomes the most accurate and sole source of as-built information. So virtual erection and simulation studies were performed based on the point cloud collected on the final welding process, and they were used for verification purposes in terms of lifting, in terms of interfacing with other as-built elements, and also in deviation analysis against design models in order to evaluate the magnitude of change during this fabrication and fit-up process. The virtual simulation were performed for each component and stage of the primary steel package. However, the giant dimensions of the members, that in certain cases they may exceed weights approximately or greater more than 400 US tons, spanning over 110 feet, was a very challenging exercise that the laser scanning performed exceptionally well. The interfaces between adjoining members were collected and controlled based solely on laser scanning, and we achieved great accuracies. Specifically, the scans associated with these measurements, they didn't exceed the range of plus minus 1 millimeter, and we are extremely proud for getting so deep into this accuracy exercise and provided so trustful results to the project for undertaking this kind of complex works. Lifting simulation is also of paramount importance in such a size and self-weight of members. So the lifting itself was virtually processed in BIM by using the point cloud geometry, and we created some sequential steps that was a part of the official lifting report that we submitted to the client for approval. So even the lifting people and the people who are engaged in designing such a complex lift, they took the advantage of having a point cloud in place, having a virtual simulation that revealed all the as-built conditions, not only for the member which is currently under a lifting process, but also for the difficulties that they have to face on the landing of those elements. Now, upon completion of the works and achieving the final direction of each member, there is also another set of scans that somehow creates the final state of the erection process, and we can consider it as, let's say, the fixed and final position of the member, which is evaluated again by using such a rich amount of as-built data. We can produce reports at the fashion that serve every need, and it might be understandable by anyone, no matter if he's been a user or not. Now, all the above mentioned are summarized in 1 minute video, which was produced by the general contractor, or specifically the case that we described. And you can view it for your reference. Okay, it seems that the sound is not available, but in this process you can see how a compression ring segment is transported by the SMTP units and is currently under lifting stage by a high-capacity crawler crane which may exceed the 1,200 tons at one go, as you can see. And this is the closing segment which is put into place, as you can see, with great accuracy. That's the end of the first part of this presentation, although we may experience some technical problem. But I'm quite sure that the second part will go forward without any difficulties, and David is there to present you some very informative slides from his end as well. Thank you.
Okay, well, hello everybody. Again, thank you for joining us for the presentation today. My name is David Burzik and I'm with Trimble. Trimble is a manufacturer of scanning technology as well as geospatial and building construction layout technology using robotic toll stations. My particular focus within Trimble is on the development of our 3D capture solutions. And so what I want to talk about in the presentation today is just talking about some of the industry trends that you're seeing with the use of the scan data. What you saw from Leo in his presentation is a great example of how the scan data is now being implemented as part of the overall construction process. And that's a lot of what the trends are that I'm starting to see, as well as scanning is starting to be more and more embraced within the AEC industry. But what I wanted to start with, is the question of why 3D scanning. Within the overall industry, there's more and more of a demand now for what are called constructible models, being able to have very accurate modeled information that represents what actually got built on the site. So from designing things to make it fabrication level ready, to then taking out to the job site and getting it manufactured and put in place, just like what Leo was showing in his presentation. There's a very large demand for that type of application in the industry today. There's also this requirement to document what I like to refer to as the as-is condition. As things are being built throughout the process of construction, project owners want to have things documented accurately, so that if they have to come back and do retrofits to a project later in the life cycle of the building, or if they're doing future master planning with the building project, they want to have this accurate as-is information that they can use as part of their planning process. But then also being able to document those as-is conditions allows people to do pre-construction planning. Being able to really determine how you're going to do your site logistics, where you're going to be doing placing of materials on the site, and what's the sequence of construction from start to finish. Scan data is also used for renovations. That's probably its major use that is traditionally always been used for, going out to a job site, capturing the images for projects where you may or may not have any type of design information to work from. And then as what you were seeing with Leo's presentation was, it's being used to track the progression of construction. And also being used as a project deliverable, to where during the construction process, as things are being put in place, scans are being taken to do the quality control checks to ensure that all that upfront planning work that was being done from the coordination process is actually being installed out to the field. So you're seeing that kind of progression of construction being documented through the use of 3D laser scanners. And then also a big use of the scanning now is around construction verification. And Leo had great examples showing how the scan is being used to verify the level of precision that's needed, especially with the steel members being used on complex projects like the stadium that he was showing. And so that's why scanning is starting to be more and more embraced within the industry. It's a technology that allows you to be very fast and efficient on a job site with your time. And it allows you to get very accurate information in a short period of time, and then being able to implement it on the complete project. So I want to just go through a few examples of just some of the ways that the scan data is being used on projects, and you may be familiar with these and some you may not be familiar with. The first example that you see on the screen is probably the most common use of scan data within the industry, and that's just to use it to create very accurate as-built models of job sites. In this particular example, you're seeing two images here of a project where it was with a contractor that I was working with. It was an electrical contractor, where they had done some work on a wastewater treatment plant. And on that particular project, the owner was requiring at the end of the project that all the new equipment that was being installed on the project site be scanned and then turned into a 3D deliverable. In this case, they were creating a Revit model that was being turned over as a 3D deliverable at the end of the project. And so on the left-hand side of the screen, you can see the scan data that was used to capture their conditions of everything that they had installed as new systems. And then from that scan data, they started to extract the model information. And so on the right-hand side, you see an image with the scan data turned off to see how much information they were able to extract from the scan data to produce that very accurate LOD 400 model that showed what was installed on the project site. And they turned that over to the owner at the end of the project as a deliverable to them. And so this is how, one of the most common uses of scan data on the project. But just like what Leo was showing with the steel fabrication, new ways of scan data being used is that, if you look at the 3D laser scan, that really becomes your constructible model. It is a model because it's a 3D representation of the environment. And so you're starting to see hybrid models of both scan and model data in where it's being used for prefabrication of any kind of prefabricated units. So in the example here, this is from a mechanical contractor in which they were working on a boiler room where they were going to install a new pump assembly on an existing system, but they didn't have any drawings to work from to begin with. So they came into the project, scanned the boiler room where this new assembly would be going into installation, and then they brought it back into their detailing software. And so they took both the point cloud and then modeled only the connection points for where they would have their flange connections. And that became their working drawings that they worked from to create the prefabricated assembly. And so then as they started to work with that information, they then were able to bring in that new prefabricated assembly to ensure the accuracy of the construction, the accuracy of the connection points, and then be able to take that information so that they knew when this assembly left the shop and went out to the job site for installation, that it would line up exactly where it needed to with those connection points and not cause any errors or any delays in the overall construction of the project. And so you saw similar examples with what Leo was presenting with that steel fabrication. The same kind of workflows are being implemented on mechanical and electrical workflows as well. And then another use of the scan data from a general construction standpoint is also just documenting where rebar is placed before concrete pours. Because the scanning technology is so fast at being able to capture the scan data, and now with scanning solutions coming out that actually do registration out in the field as you're collecting the data, contractors are implementing it to start to document job site conditions as they go. And so a very common use is around concrete work, where contractors will go out ahead of the pour and run their laser scanners across the deck and scan where all the rebar is placed, or in the example here on the screen, this is a post-tensioned cable deck. And so what they want to do is document where all those post-tension cables, which you see in red, were being placed on the deck. Because when those get put under tension after the concrete is poured, if you have to make any changes to the design, you're very limited in where you can make penetrations in the slab, because you don't want to hit one of those cables and release all the tension that is supporting the overall deck. And so in this particular contractor, what their workflow was is just before concrete was poured, they would run out onto the job site, take their laser scanners, and they would capture a pre-pour scan, and they would take that information and drop it into their 3D model. So that's what you're seeing on the screen here, where you have the model information overlaid with the pre-pour scan. Then after the scan was collected, then they come back and or after the concrete was poured, they would come back and take another scan of the post-pour conditions, and then also overlay that information into the model. And the benefit behind this is that then now if they had to make any design changes, they had a very accurate representation in the model of what the real world conditions were. So if they had to make any type of design changes in terms of where sleeves are being located within the deck or anything of that nature, any type of penetrations in that deck, they didn't have to stop the construction process. They could actually go back to the model, look where there would be a safe location to make a change in terms of the location of the sleeves, and they could make those adjustments in the model. They could take the coordinate locations of those new penetration locations, load it into a robotic total station, and then that total station can point out the accurate location for where they could safely drill through the deck. So this becomes a very nice workflow for them to be able to document those conditions and still be able to address any changes that might pop up without delaying the overall construction schedule. And then now with the ability to go through and do these types of analysis out in the field where the scan data is being registered as you capture the data, more and more analysis is being done using the scan data. And so a great example is doing a floor flatness analysis. This is where you take the scan data, run an analysis, and you identify, especially in existing construction, where the highs and lows are on the deck that you're working on. And in the cases of new construction, when concrete gets poured, you have a very short window of when you can continue to work the concrete when you have the highs and lows within the slab. And so the ability to take that scan data, run this analysis to where you get this kind of heat map and also a contour model showing the highs and lows, that information can then now be loaded into tablet controllers that are being used out in the field to capture the scan data and also being used to lay out information. And you can overlay all those pieces of data to enable the teams out in the field to have more information around what they want to do in terms of addressing where highs and lows are or how they need to address any issues out on the job site. So you're starting to see this type of use of the scan data being implemented with the overall construction layout process as well. And so that just helps to educate the teams in the field so they don't delay the projects, but they're able to make very informed decisions around where they have to make changes or anywhere that they have to do any kind of their layout work. And then the last area that I want to just talk on before we open up for questions for the presentation is where are things going around this technology? And so it's really starting to look at the use of autonomous robots. What you're seeing on the screen here is the Spot Dog from Boston Dynamics, in which you're having the ability to take a scanner. So in the case here, this is the X7 laser scanner from Trimble, and you're mounting scanners on these autonomous robots that can then start to do repetitive routes around a job site to be able to document that progression of construction. There's a real interest around this ability to take this technology and really capture, what's the progression of construction over a consistent time frame. Because of the fact that being able to access the data is becoming more and more easier. Projects are starting to make this part of the typical workflow. The scan is being treated as a model. The ability to have this kind of a robot go out and be able to capture things on a more frequent and regular basis really helps to inform decisions that are being made on the project as issues come up, or in the case of doing quality control checks, being able to see that things are actually being installed as they are coordinated. So you're starting to see a lot of work around this particular area where the use of these types of autonomous robots are coming in to take advantage of the technology and the deliverables that you get from the overall scanning process. But there are lots of different trends that are starting to happen. But the overall theme around the scanning in general is that it's very useful information that gives you highly accurate information of the project conditions in a short period of time, and it becomes that kind of 3D deliverable that represents those as-is conditions. So with that, I will hand things back over to Bimal, and we can open it up for questions.
Thanks, David. Thanks, Leo. I think this was one of the most compelling presentations that I've ever seen. And as they say, seeing is believing. I think the examples that both of you have put on the presentation, the real life examples, the videos, they were really compelling. Now, Leo, my first question to you, and that is some of the audience, they are very curious to know that you are doing such a big, large stadium, 92,000 people, and such a huge stadium in a very short time. So you must be having a big team for the laser scanning. So how many laser scanners you had, and how big was your team?
Yes, Bimal, in this project, as mentioned in the presentation, The laser scanning is an employee requirement, not only for the general contractors, but also for the entire supply chain that deals with, let's say, critical components of this project. So whoever was involved into the production of the roof, facade, and primarily steel package has to own a laser scanning and follow the requirements that we have set as a general contractor in this job. So that means that every party had to have one or two laser scanners to satisfy the demand, and according to our specification, to provide inputs and outputs as per the requirements. The general contractor, as for ourselves, since we are representing the general contractor here, it has one laser scanner, okay, which works almost 24/7 in this project. Of course, steel fabricators on the shop, they may have multiple machines which have an industrial orientation in terms of scanning, depending on their production.
And I believe you had only one person in the team, right, who was doing the laser scanning as a BIM, overall BIM coordinator.
Yes, in our project, this may be differ from organization to organization. In our project, the project implementation plan was somehow was set out on the principle that the BIM team will take control over the laser scanning activity. So this is an enhanced, let's say, BIM team that is taking over that much critical operation in the project.
Thanks, Leo. In fact, it is. You can switch off your please. Okay, thanks. Friends, let me give you some background to this project that we have done. Now, Arvind, who was the laser scanner, who was our engineer on the site, he had not even seen the laser scanner when he arrived at the site. And with just 2 years of experience in the industry, Arvind could, with a very small training and guidance by Leo, the team could scan the whole project. And it was unbelievable, and it was not a requirement for all the other subcontractors, but it was so compelling that each and every contractor and trade contractor, they started using the laser once they saw the benefits. And it is amazing the kind of work that has been done on the stadium. Leo, what do you think if we had not used the laser scanning for this construction verification? So the big steel frames that you raised, how many attempts it should have taken if it was not verified by laser? What is your experience? On an average, how much time and how much costs we saved? What are the benefits we brought on the table by using laser scanners?
The laser scanners, in the beginning, when we approached the general contractor to establish this kind of implementation, the reaction was, let's say, the general contractor was very shy in going in that much of technology. However, without any doubt, I can surely assure you that without laser scanning, this project cannot be implemented and progressed in such a stage as is today. As shown in the presentation, the laser scanning is a core activity, okay, within a process that without undertaking the works of laser scanning, you cannot progress on the next step. So we are talking about risk elimination, okay? We are talking about enhanced decision making. we're talking about evaluation of potential risks that are met beforehand. We're also emphasizing on the efficient control that we took over our subcontractors. We eliminated error-prone observations that you may get from a conventional approach. Definitely, I cannot make an estimate about how many millions that we saved, but the actual cost of procuring and implementing a laser scanning process compared to the savings that the laser scanning has provided in this project is enormous. Okay, I cannot even approach a number, but it is definitely a great return on investment in critical projects. Okay, and in projects of incorporating, generally speaking, various risks.
Excellent, Leo. I think that's a commendable job by the team, and everybody, when all the stakeholders, they start using the technology, then we really benefit from that. And I know that how tight schedule you're working on, and the kind of the size of these steel frames and the structures that is being lifted and the size of the cranes, just imagine taking something up there on the 6th level and 8th level and finding that it is off by 1 centimeter, and then again bring it down and again correcting and taking it up. So the safety, the time, the cost, everything has been tremendous beneficial for the project. Now, David, Leo has been telling us about the ROI. So I would like, in fact, a lot of audience is very interested in knowing the costs of training people, the cost. What are your experiences? How much one needs to invest, and what do they need to do to start using the lasers in their construction workflow?
Sure. So the cost for the technology itself, what you're starting to see now is you look for kind of complete packages that when you go to purchase the hardware, you're also getting the software added in, and training usually ends up being kind of a separate cost, but that gets added as part of that overall package. But your prices will range, anywhere from $30,000 to about $40,000 now. In some cases, it may go up to $50,000, really depending on what the solutions are that you work with. But you're getting a complete package when you get that purchase. A lot of the training or the investments that you have to focus on is around your computers as well, making sure that the team that will be using this data has a robust enough computer that can handle the 3D models, can handle the scan data. Scanning data files in general are very, very heavy in terms of they're very large files to work with because you have millions of measurement points. But what the different software vendors out there like Trimble are doing is working on ways to provide much more efficient scan data files to where they optimize the data to make it easily transferred between different stakeholders. But you have to make an investment to ensure that your team has the right computing power in addition to the hardware that gets purchased. But you make that initial investment. The training usually, in the case of our solutions, is usually about a 2-day event that happens after the purchase of a scanner, in which the first day the focus is around just the technology itself, understanding the software, understanding the technology, and then the second day is taking that knowledge gained from day one of training and going onto a job site like the project that Leo shared, and then just doing the workflows there in the field. So that then the people who will be the operators and the users of the scanners will have a good understanding of the technology. And understanding the process of capturing scans is pretty easy to pick up. It's a pretty straightforward process. Where you'll spend most of your time and your energy is then taking that data that's collected and turning it into a deliverable. And so the different types of processes, like what Leo outlined in his presentation, that's where you'll start to spend more of your time, is to start to use that data to evaluate it and use it as a comparison and coordination tool.
Wonderful. David, that is very reassuring because everybody is worried about the cost, and more importantly the need to train, the need to upgrade your infrastructure. But in this case, as we can see, the companies are already using BIM, they already have a good hardware infrastructure, and they just need, and as you said, in $30,000 to $35,000, they get a complete package to scan. Now, again, there are some questions on how much time does it take to complete a scan, and what is the radius that you can scan in one go. So if you can give some ballpark figures, it will really help to understand the audience.
Sure. So it really will depend upon how many scans you're capturing for a particular location, and then in terms of range, which type of scanner you're using. You have a whole range of scanners that you can implement on a project, from very short-ranged handheld devices that may only go up to 6 meters in distance. Those are really intended for highly detailed types of captures. Mid-range scanners are usually around your 80-meter distance mark. And then your longer range scanners can go up to 340 meters in terms of the distance that they are for scanning. But the thing to keep in mind when you're working with a laser scanner is that it's a line of sight device. So the scanner is only going to see what you see standing in a particular location. So it's not an X-ray machine. It can't go through materials. So if you want to make sure you get a nice, accurate representation of the environment you're in, you have to make sure that you set up scan stations in multiple locations that provide you different angles of point clouds. And those individual stations, when they get registered, become that composite representation of the space. And so that starts to determine how much time you're going to spend on a job site. On average, for each individual scan, you're probably going to spend, depending again on the instrument that you're using, maybe 3 to 5 minutes to capture a scan. There's a lot of scanners now that are doing high-speed scanning, where they scan at 500,000 points per second to 1 million points per second. And then after they do a scan, they'll do a 3D photo capture as well. And so that process can range again between about 3 to 5 minutes. And if you need higher accuracy, you'll slow the scanner down, so then that will increase your scanning time maybe into the 8 to 10 minute range. But again, it's just how you want to use the data. But then that's kind of an average time frame that you would spend per station to capture those scans. And then once you've got those scans, if you're using a system that does registration out in the field, that becomes a nice time savings for you, because as you capture each individual scan, that new scan will register back to the previous location. So that when you're finished capturing your data, you have kind of a pre-registration of the data, and then you do a refinement that then tightens everything up, and then that speeds up your overall time, because you're not having to then process data back in the office as another separate step. So you're going to spend a little more time, working with the data and processing it, but anything that you can capture while you're out in the field, from in-field registration to the number of scans you're capturing, that's where you can get some time savings.
Thanks, David. There is a very interesting question from Matt Wyckoff. Matt, we are unmuting you. We would like you to ask the question. Matt, can you hear us? Can you unmute yourself and ask your question, if you don't mind? No problem. So, David, the question from Matt is that can you combine the laser scan data with the drone scan and other scan data? How do you combine the different types of capturing of data and with accuracy?
Yes, some softwares will allow you the ability to combine all those different sources of data. A particular project or product that I use and that we have started selling is called Cloud Engine. And what it does is it allows you to bring in these different sources of data. So whether it's drone, whether it's your traditional terrestrial scans, any of the kind of SLAM type handheld capturing as well, and bring all that data into one platform so you can start to use it. So the way you ensure your accuracy, the use of targets is always a great recommendation to have that in the scan data as well, because that allows you to provide a known entity that you can use to stitch together the different sources of data. If you get things registered on the same coordinate system, just like with your 3D coordination models, if everything's on the same coordinate system, then all that information, when it comes together as a composite representation, lines up in the correct location. But yeah, you can bring all that different data to into one platform to begin to work with it and use it. And that's where it kind of comes back to, what kind of information do you need, or what level of accuracy do you need? Because each different source, has a different level of accuracy, but it has an application that might be acceptable for your particular work. In terms of drones, if you just need kind of the overall view of a site, that's really what those are great for capturing. In a very short period of time, you can capture the overall site conditions. But the drone data isn't something that you would use to do the type of analysis that Leo was presenting. That's where you kind of come back into the terrestrial types of scanners, where you can then do very high resolution scans that give you the level of accuracy that you need to be able to run the comparison and the checks for those connection points of the steel members. So the ability to look at all those different sources of data is definitely a great workflow to have within your software.
Thanks, David. In fact, we have already crossed the time by 10 minutes, but I can see more and more questions coming. Ladies and gents, what we are going to do is, please do send us your questions, email your questions. And there are a lot of questions I can see on how to handle so much of data, what is the size of data, what are the software and hardware available to process these data. We are the leading service provider in these services, and we will be very happy to share with you the details. So please do write to us, and we really thank everybody, all the audience, for being very patiently hearing. And we can see that even now almost everybody is there in the attendance, so which really shows that even after crossing our time, the people are still attending it. So that calls for a standing ovation for Leo and David. Thank you so much. And also Arvind, Leo and Arvind, they are now in Qatar at the site. And David is in US, we are in India. It's really a global world, and we have people listening from all the time zones. We have people from the Asia Pacific, from India, from Middle East, from UK, from US, Canada, and it has been an amazing audience. Thank you everybody for encouraging us by attending this. And once again, Leo and David, amazing job. A big standing ovation for both of you. Thank you so much. Have a nice day.